Using the concentration time data for the conversion of A and B to D for part A, let's write a balanced equation for the reaction. So we're going to have the conversion of A and B to D. We know that we use up minus 1 over A, change in A over change in time is equal to minus 1 over B, change in B over change in time is equal to 1 over C, not C, but 1 over D, change in D for change in time. So this will be 0.20 A over 60 is equal to 0.10 B over 60 is equal to 0.10 C over 60. Simplifying here, we get this is B's here. A over 2 is equal to B is equal to D. So our balanced equation here, if we have a single A, it would be A plus A over 2B producing A over 2D, or 2A plus B producing D, and this would be our overall equation. For part B, what is the reaction order with respect to A, B, and C, and then the overall? So from experiment 1 and experiment 3, changing B doesn't change the concentration of B. Therefore, with respect to B, the reaction order is 0. From experiments 1 and 2, doubling A, the concentration of A gives double the concentration of D. Therefore, with respect to A, reaction order is 1, and from 1 and 4, doubling C, concentration of C is double the concentration of D. Therefore, with respect to C, the reaction order is, since the reaction is first order with respect to A, first order with respect to C, the overall reaction is second order. For part C, what is the rate law? The rate is equal to K concentration A concentration C. For D, is a catalyst involved? And we can see that C is a catalyst, as it is present in the rate expression but not in the overall reaction. For E, suggest a mechanism that is consistent with the data. So at A plus C, that will produce AC. This would be a slow step. And then you'd have AC plus B to produce ACB. This would be fast. And then we'd have ACB plus A to produce D plus C, and this would be fast. And then our overall here would be 2A plus B to produce D. And let's calculate the rate constant for the formation of D for part F. So the rate is equal to KAC, which is equal to change in D over change in time. Therefore, K is equal to 0.10. This would be 60 times 5 times 1, which is equal to 3.33 times 10 to the negative 4. Put the correct units here. Molarity minus 1, seconds minus 1. And there is our rate constant.